Good morning students. Now we are going to see the lesson dual nature of radiation and matter. First we will recap what you are prepared in the last class. First one is laws of photoelectric effect. Remember what you are prepared in the laws of photoelectric effect? Photoelectric effect, that is photo current, is directly proportional to intensity of incident radiation. Then there is a minimum frequency below which the photoelectric emission is not possible. Then the next one, the maximum kinetic energy depends upon the frequency of incident light independent of intensity. And the next one is it is an instantaneous process. The next heading what you are prepared is the characteristics of photons. Photons, no mass, no neutral, it is neutral, no charge. It is not deflected by electric and magnetic field. Photons moves with the velocity of light, that is 3 into 10 power 8 meter per second. Now, the next one, that is the last one what you are prepared is Einstein explanation of photoelectric equation. Remember, when the light rays or any electromagnetic waves that falls on the material side, immediately the photoelectrons are emitted from the metal surface. So, this photons energy h mu, that is split into two ways. The first part of the energy is used for work function, that is to remove the electrons from the metal surface. The remaining amount is converted into kinetic energy, that is h mu value equal to the value of work function is h mu 0 plus kinetic energy. Now I want to calculate the value of kinetic energy, means keep kinetic energy one side, the remaining one move other side of the equation. Then you will get kinetic energy value is equal to h mu minus h mu 0. Or you know h mu 0 is work function, that is replaced by pi 0. Then the next one is h mu value equal to h mu 0 plus 1 by 2 mv square, because you know the formula for kinetic energy. Kinetic energy formula is 1 by 2 mv square. And the kinetic energy, relation between kinetic energy and the stopping potential also a known one. 1 by 2 mv square value equal to EV0. So replace 1 by 2 mv square and EV0. So depends upon what is given in the problem side. If the kinetic energy value is given, means use the formula h mu 0 plus kinetic energy, the photons of energy equal to. Mass and velocity is given in the problem side. Use h mu value equal to h mu 0 plus 1 by 2 mv square. If the work function value is given, so use pi 0 plus EV0. The stopping potential value is given, means use this formula and calculate the value of threshold frequency or threshold wavelength or unknown frequency, like that. Okay, now this class you are going to see about the explanation of photoelectric effect. What all the things experimentally verify, that you are going to see. The intensity of incident radiation increases. When it is increases the intensity of incident radiation increases, means the emission of photon also increases. Emission of photoelectrons value also increasing. The emission of electron increasing means the photoelectric current value also increasing. So, intensity increases means the photoelectric emissions, that is emission of electrons, also increases. Electrons value increases means the photoelectric current value also increases. That is the first one. Now you are going to calculate the value of kinetic energy. Maximum value of kinetic energy means use this formula h mu minus pi 0. You know pi 0 is a work function, that value is equal to h mu 0. Mu 0 is a threshold frequency. So the kinetic energy, maximum kinetic energy depends upon only the value of frequency. It is independent of intensity of incident radiation. And you know this also, that is the minimum frequency you need for the emission of photoelectrons. After that only the photoelectric effect start. The minimum value of frequency, this is called threshold frequency, below which the photoelectric current value equal to 0. Okay, now it is an instantaneous process, you know. That means when the light rays or falls on the metal surface side, immediately the electrons are emitted. So it is an instantaneous process. Okay, now the nature of light wave. That means when it is behaves like a wave, when it is behave like a particle. So the first case, that is interference. Interference, the light wave, that means the light wave act as a wave nature, that is behave like a wave nature. The next one is diffraction. In the diffraction side also, this light wave that act as a wave nature. Then the third case is polarization. Polarization side also this light behave like a wave nature. So these three cases light behave like a wave nature. Then when it is behave like a particle nature, because it is a dual nature. So when it is behave like a particle nature in black body radiation. So in black body radiation the light wave behave like a particle. And the second one is what you are going to see now, that is the photoelectric effect. That case also this behave like a particle, that is the light behave like a particle. Okay, now when you are going to learn the new one is photoelectric cell. So photoelectric cell converts light energy into electrical energy. The light energy is converted into electrical energy. What is the principle of photoelectric cell? That is photoelectric effect. That is the principle of photoelectric cell. What are the types of photoelectric cell? Totally 3 types are in this side. The first one is photoemissive cell. So this is photoemissive cell. So the light rays are falls on the metal surface side, immediately the electrons are emitted. So this is photoemissive cell. The second cell type is photovoltaic cell. So this is photovoltaic cell. So see, this is a semiconductor. So the semiconductor that produces the voltage, that depends upon the intensity of incident radiation. The incident radiation intensity value is increases means the potential produced in the photovoltaic cell value also increases. Then the third one is photoconductive cell. So this is photoconductive cell. So the resistance of the semiconductor here it varies, depends upon the energy of a light. So 3 types in this side is photoemissive cell, photovoltaic cell and photoconductive cell. Now the next one is only one you are going to see is photoemissive cell. All the 3 cases you are going to learn only one photoemissive cell, the construction and the working of photoemissive cell. You see, this is a quartz bulb. Inside the quartz bulb, collect, that means emitter and collector, that is cathode and anode is present. You see the cathode, it is a cylindrical shape. The cathode is a cylindrical shape and the anode is a, which one? It is a thin wire, maximum it is a tungsten wire. This cathode is coated with any photosensitive material. The cathode and anode both are connected with the help of the power supply. The potential difference is applied in between the cathode and anode. When the light rays or falls on the metal surface, that is the emitter side, that is the cathode side, the electrons are emitted from the cathode, that is attracted by the anode. So the movement of electrons that produces the current produced is measured with the help of microammeter or a galvanometer. It is used to measure the value of current produced in the photoemissive cell. The next one is the application where you are using this photoemissive cell. What are the application of photo cells? The first one, it is used as a switches and sensors. The second one is it is used in the street light sides. So switch on or off according to the weather. It is day or night. According to the weather, it is used in the switch on or off in the street light side. And the third one is reproduction of sound in motion picture. And the fourth one is it is used as a timer. So it is used to measure the speed of the athletes. So speed or want to measure means you are using the photo cells to measure the timers, used as a timers. Then it is used to measure the intensity of given light. So these are the application of photo cells. You see, this is the diagram for the photo cell. Now the next one, small problem in this side is a radiation of wavelength value is given 300 nanometer, that is incident on the silver surface. Will the photoelectrons are absorbed or not? Photoelectrons be absorbed or not? That is the question. So what is given? The wavelength value is given, that is lambda value is given. Lambda value is equal to 300 nanometer. You know the nanometer value. 1 nanometer value is equal to 10 power minus 9 meter. So lambda value equal to 300 multiplied by 10 power minus 9 meter. Which one you are calculating? The photoelectrons are absorbed or not? That is the question. So now, first you are calculating the value of energy. You know the formula for energy. Energy value equal to h mu. But the frequency value is not given in the problem side. Only the wavelength is given. So you know the formula connecting velocity, frequency and wavelength. C value equal to mu lambda. So I am rearranging mu value equal to C divided by lambda. Substitute the value of mu in this equation. So the formula is Hc divided by lambda. Okay, actually C values, that means the energy value in terms of joules only, but you are going to calculate this type of problems in terms of electron volt. So the formula is divided by the charge of a single electron. You know the value of charge of the single electron, 1.6 into 10 power minus 19. So the value divided by the charge of the electron means you will get the answer in terms of electron volt. Okay, so now you substitute all the values in the formula side. E value equal to the value of H is 6.626 into 10 power minus 34. This is Planck's constant. Then the velocity of light is equal to 3 into 10 power 8 meter per second. Wavelength value is given. You are converting the answer in terms of electron volt. For that you are using 1.6 into 10 power minus 19. 6 and 3 you are multiplying means the answer is equal to 19 point some value. You see here 10 power minus 34. Here 10 power plus 8. Then the answer is equal to 10 power minus 26. You see in the denominator side 1.6 multiplied by 300 means the answer is equal to 480. Multiplied by the power is 10 power minus 9 and 10 power minus 19. Then totally 10 power minus 28. 19 divided by 4, 480. Then the answer is equal to 0.0414 into 10 square, because the denominator side, remember what value is there? 10 power minus 28 is there. The numerator side 10 power minus 26 there. So when you are moving to the numerator side, you will get plus, so plus 2 I am getting. So this multiplied by 100 means the answer is equal to 4.14 electron volt. So you are getting the answer in terms of electron volt. The next problem is, when a light of wavelength 2200 Armstrong unit on Cu, that is copper, photoelectrons are emitted from it, find the value of threshold wavelength, stopping potential. What is given? The work function of copper is given 4.65 electron volt. In terms of electron volt it is given. Okay. So now first step, you want to calculate the value of threshold wavelength lambda 0 value equal to what? You know the formula for work function, pi 0 value equal to h mu 0 in terms of threshold frequency. Relation between frequency and wavelength is C value equal to mu lambda. So calculate the lambda from this side and substitute threshold wavelength value equal to, you will get h is a Planck's constant, value is a known one. C is velocity of light, value is a known one. And the work function value is given 4.65 electron volt. So you have to convert in terms of joule. So that multiplied by 1.6 into 10 power minus 19. The numerator value you are simplifying means 19.878 into 10 power minus 26. Denominator value 7.44 into 10 power minus 19. So when you are simplifying this means you will get 2.6717 into 10 power minus 7. So now how we'll convert into Armstrong unit. So Armstrong unit means you want 10 power minus 10. So now I am moving one digit, 10 power minus 8, minus 9, minus 10. 10 power minus 10 value is equal to Armstrong unit. So this is the value of threshold wavelength lambda 0 value equal to what? Then second step, you want stopping potential value equal to what? For that stopping potential, first you will calculate what is the energy of photon. Energy is calculated by same E value equal to h mu. Mu formula is equal to C divided by lambda. So same way, substitute the value of h is equal to what? C value equal to what? And the lambda value is given in the problem 2200 Armstrong unit. So numerator value or multiplying means this answer. Denominator value, substitute the value of wavelength in this side. So when you are calculating the value, so E value equal to, the numerator answer is 19.878. Remember h multiplied by C, always you will get the same answer. Divided by the wavelength value 22 into 10 power minus 10. I changed 10 power minus 8 in this side. When you are simplifying, the answer is equal to 9.035 into 10 power minus 19 joule. But you want to convert in terms of electron volt. So this multiplied by 1.6 into 10 power minus 19 means I will get the photon energy value is equal to 5.65 electron volt. The third one, stopping potential is a question mark. So I want calculating the value of kinetic energy, maximum value of kinetic energy with the help of the formula h mu minus pi 0, that is work function. So h mu value equal to 5.65 and the work function value is given in terms of electron volt. You are subtracting means the answer is equal to 1 electron volt. So K maximum value equal to in step of stopping potential EV0. So now you are calculating the value of stopping potential V0 value equal to K maximum divided by E. K maximum in terms of electron volt. So 1 multiplied by 1 electron volt is equal to 1.6 into 10 power minus 19. So divided by 1 into 1.6 into 10 power minus 19. So both the values are cancelled means the stopping potential value is equal to 1 volt. Students, don't forget to watch enrichment video. Thank you students.